Hey there and welcome back. Welcome back everybody. So today in this video we are going to be doing nomenclature. Lovely. And so these are actually taken, all of these nomenclature examples are taken directly from the exam review. So I did not change any of these. And so we are just going to go through a couple of them to make sure that we kind of understand our rules of nomenclature, because this does become relevant, especially as you move on to higher chemistry classes. You're going to have to know it again, right? So I think, why don't we start with this one? This one right here. So Cu2SO4. They're giving me my formula already, so I can say, hey, these are my formulas, and these are my names. So I have a formula, and it wants me to name it. So the first thing I notice about this one in particular is that I see a polyatomic ion here. I see a polyatomic ion. So that probably means its partner over here creates another ion. And these will come together and form this compound. So what I like to do is I like to separate big ones out like this into their respective ions, so it's easier to name them individually to then name them together, right? So I know that I have a polyatomic SO4, and I know that this is sulfate. This is my sulfate, right? And it has a charge of 2-. So SO4 2-, this is just a general polyatomic that you should definitely know by now, right? Know your polyatomics. So I have that one, and next I just have to figure out, what's this? What's this doing over here? Cu. So Cu is copper. I know that it is copper, and I also know that copper is actually a transition metal. So if you remember with our transition metals, they do not have static charges. We have to depend on whatever they are coupled with in a compound to determine their charge. So if sulfate here has a -2 charge, and I have 2 coppers in my compound, then that probably means that each copper has a +1 charge. So it would be Cu+. Now, when we're naming these, I try to name these ions separately first before kind of doing it, putting it all together. So I know that this is a sulfate ion. The question is, how do I name this one, right? So if you remember, with our transition metals, we do have to have our charge in parentheses. So I know that it's a copper 1 +1, so I'm going to put 1 here, copper 1. And then I'm going to put ion behind it. So I have successfully broken apart this compound, named both of its ions, and now the last thing to do would be to come over here and put it into a name, right? What is my official name of Cu2SO4? So always start with what comes first in the formula, which is going to be our copper ion. I'm going to come over here, I'm going to drop ion, and I'm just going to put, hey, I have copper 1. Very cool. The next thing is I'll take the second component of that compound, which will be my sulfate ion. And I'll drop ion, and I'll just plug in sulfate right here. So Cu2SO4, the official nomenclature is copper 1 sulfate. Amazing. So let's find another one. Let's find another one we can do. I think this one might be worth doing, this MgBr2 here, right? So this one's a little different. I look at it, there's no polyatomics. Cool, whatever. But I do see, I'm like, hey, what are these? Magnesium and bromine. So I'm thinking I have a metal and a non-metal paired together. Awesome. So I do know also that they do break down into individual ions. So if I remember, I go to my periodic table and I say, hey, magnesium. Magnesium turns into an ion. What's the charge on it? It is 2+. And this is a magnesium ion. Cool. I can come then and look at the second part, which is bromine. And bromine just has a -1 charge, -1 charge on our periodic table, right? You'll have to go back if you don't know these charges and review oxidation numbers for sure. But we know that this will be a bromine, or in other words, bromide, right? Bromide ion. Anything that is a singular element with a negative charge, meaning that it is an anion, the ending will be changed to "ide" every single time, right? So this is going to be a bromide ion. So I've pulled it apart. I've named both my ions individually. So I'm going to come over to the nomenclature section and I'm going to try to write it. Start with the first thing in the compound, which is magnesium. So I have magnesium. And then come over and put the second thing down. You remember, you don't need to include the word ion, you just need the name. So this compound is magnesium bromide. Woohoo! Fantastic. Okay, let's see. Blah, 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 la, 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 la. Let's try one the other way around. So I always like the acid examples because I think the acid nomenclature rules are, they're a little bit more complicated, right? So I'm going to start over here and I'm going to go, hey, sulfurous acid. What the heck is that? How do I even name that? That's wild. So with these, the first thing I'm looking for when I see acid is, does it have the prefix hydro? Does it? No, it doesn't. So when we have the prefix hydro, and there are other examples, like if you look up a couple, I have hydrosulfuric acid up here. Hydro means that this is a binary acid. So it will be one element plus hydrogen. But I know that that is not the case, right? Because I don't have a hydro prefix. So I know that since it's not one element plus hydrogen, it's probably going to have a polyatomic ion in it. So then I have to come and I have to say, hey, just looking at the word sulfurous, is there any possible polyatomic that's in there that I could be like, hey, oh, I know exactly what that is. Yeah, cool. So I think to myself, I'm like, okay, could it be something with probably sulfur, right? Sulfur. So it could be SO4, could it be SO3, who knows, SO2. Not really sure, right? But that's what we have to figure out. So I'm like, let's try SO4, 2 minus. Oops, 2 minus. So this is sulfate. We already kind of went over this one, right? So the thing about our ion nomenclature and our acid nomenclature is that when we have an 8 in our polyatomic, the ending of the acid will be ic, right? However, if I had sulfite instead, right, sulfite, the ITE ending would actually lead our acid to have an OS ending, OUS. So then I have to question. I'm like, okay, well, which one is it? I know the main component is sulfur, and it has an OUS ending. So it's probably sulfite, right? It's probably sulfite. So for all intents and purposes, oh, thank you so much. I'm going to erase my sulfite stuff right here. Awesome. So sulfurous acid, it's going to be sulfite, which is SO3, 2 minus. Amazing. So I have that. I have my SO3, 2 minus. And that's really the main component of it, is figuring out which polyatomic ion fits our rules. Ite goes to os, and that means that is our main component. So I'm going to come back over here, and I'm going to say, okay, I have SO3, 2 minus. The next big things about acids that we have to remember is that it's always going to be paired and balanced out with hydrogens. So I need at least one hydrogen, to make this an acid, okay? The next part is, hey, how many do I need? Each hydrogen is only +1. And if I need this to be a net neutral compound, I probably am going to need one more hydrogen in this case, right? So two hydrogens. And we look, those two positive charges balance out. Sulfites, two negative ones. So if I put this together, it's going to be H2SO3. Remember, we don't need to add the charges. This is a neutral compound. But H2SO3 will be sulfurous acid. Amazing. It has a little bit more work. However, it's cool. We're chilling. We're chilling, right? So let me do one more example. If I come down here, and I think this one would be good, right? HBr, because we have been talking about acids. So this is an acid, but it's a different kind. I don't have a polyatomic in this one. I have hydrogen and one element. And that makes this a binary acid, right? I talked about this a little bit with the other acid that we were doing. But so with binary acids, the first thing we always do is we start with the prefix hydro. Hydro. So you're basically halfway there at this point. I'm going to put down hydro because I know that's going to be in it. The next thing you want to do is you want to say, hey, what is my core element that's not hydrogen? And if I look here, it's bromine. Bromine's my core element. So I'm going to put that after my hydro. Hydrobromine. So this is almost right. However, when we do this core element naming, whatever element it is, you're going to give it the suffix of ic. Ic. So instead of being hydrobromine, it will be hydrobromic. Hydrobromic. 3 different parts, and then you just stick acid on the end of it, right? So these are just a few examples of nomenclature. It is, it's a lot. There's a lot of different rules, but keep practicing, and this answer key is also online.